Well, greetings everybody. I want to make what I hope to be is a quick video about type 1 and type 2 errors, and my plan is to work up to doing this question right here, which I get from my math lab. And if that's all you're interested in, you can skip to that part of the video, but otherwise I want to start with some context for type 1 and type 2 errors. And the discussion around those all comes down to having a hypothesis, okay? A statement about the world that is under investigation, okay? And as a result, a hypothesis might turn out to be proven true or proven false, okay? So a hypothesis, something you believe, something that may or may not be true but is under investigation. Now, that's on the side of reality. The other side is what we believe, okay? So we may be deciding to believe or disbelieve whatever the hypothesis is. So if the hypothesis could either be true or false, and on the other hand, we could either believe it or not believe it, it could work out that we could be wrong in different ways, okay? So there's like two different ways we could be wrong regarding the hypothesis. Give an example of how that might work out, how there are two ways that you could be wrong. Now, maybe you see what I'm alluding to is there's two types of mistakes we can make in statistics, type 1 and type 2 errors, all right? And then here I just said, look, with regarding a hypothesis, there's two ways we could be wrong about it, okay? So I'll try to give a real simple example, something like simpler than anything that I think you'll see in my math lab, but it might allow you to get a feel for how there are two ways that we can be wrong when it comes to statistical hypotheses. So say I have this hypothesis that all house cats are gray. So here's my cat Melvin, and he's gray, or at least he looks gray to me. And so let's pretend like he's the only cat I've ever seen. I think, well, I guess all cats are like that. All cats are that color. So I've got this hypothesis that all house cats are in fact gray. So, all right, let's like work under that kind of assumption. Now, my decision or your decision or anybody's decision about this hypothesis is that they either accept it or believe it and think that all house cats are gray, or that they reject it or disbelieve it and they think that something else is true. I've seen an orange cat before, or I've seen a white cat before, or a black cat before, or whatever, right? So you either believe my hypothesis that I'm putting true or that I'm putting forward for you, or you disbelieve it, okay? The other side of the coin is reality, okay? Reality does not care about what you believe. So it might turn out that the hypothesis is true and all house cats are gray, or it might turn out to be that the hypothesis is false and all house cats are not gray, okay? So there's like two sides to what we believe, and there's two sides to reality with respect to the hypothesis. Now, here's where type 1 and type 2 errors come in. If we believe that all house cats are gray, and it turns out that's true, then we're right, and we didn't make a mistake. We're not wrong, okay? Or we could disbelieve that all house cats are gray, and reality is in fact that all house cats are not gray. Well, then we're correct again. So there's two ways we could be right with regards to our beliefs and what reality works out to be. The ways we could be wrong is if we believe that all house cats are gray, but that turns out not to be true. That turns out we look around and we find some white and black cats and so on. That's a type 2 error, okay? But we're wrong. The other way that we could be wrong is that if we disbelieve that all house cats are gray, okay, so we reject the hypothesis, but then it turns out to be true that all house cats are actually gray. So we're wrong that way too, but we're wrong in a different way. So that's called a type 1 error. So you see there's two ways we could be right, and there's two ways we could be wrong. So as far as the mistakes we can make or the ways that we could be wrong, we call it a type 2 error and a type 1 error, okay? So you might think of it like this. We accepted we believed something that turned out to be false, okay, type 2 error. Or the other way that we could be wrong is we disbelieve something that turned out to be true. That's called a type 1 error. Now I know that maybe before the video, you might just looked at it as we're either right or wrong. And, I can't argue with that. But in the context of the study of statistics, we do classify the ways that we could be wrong with type 1 and type 2 error. So I hope that this example lets you see that all I'm trying to do with type 1 and type 2 errors is classify the two ways that we could be wrong regarding our beliefs and reality. Okay. All right. Now, I know that for my example, you'll have to get past this hypothesis. You might think it's ridiculous, and you already know that it's not true that all house cats are gray. But you have to look past that. It's just supposed to be a simple example. All right. Okay. But I hopefully outline with the table what I'm working up to with regarding the kind of thing that we might see on my math lab. Now, so let's do this. I want to go to this part. If I need to build that up, what I just showed you, and put it in the context of something that is statistical or mathematical, because there's nothing mathematical about thinking house cats are gray or not or whatever, I need to talk about null and alternate hypotheses. Okay, so it works like this. A null hypothesis is a mathematical claim that involves equality, and an alternate hypothesis is what we would believe if we reject the null hypothesis. Now that might sound like a lot, but I'll show you with some examples all the possibilities. So if a null hypothesis is a mathematical claim that involves equality, it might be like this. The average test score was 82. That's like saying the average test score was equal to 82. There's the equality, the equals. Okay, X bar is the mean or the average. That's the way that we might see it. We put H with a subscript O right there to signify the null hypothesis. All right. The alternate hypothesis, what we would believe if we rejected the null hypothesis. Well, what's the alternative to thinking the average test score was 82? Thinking that it wasn't 82, or that X bar is not equal to 82. So it's like these are your options. It's either 82 or it's not 82. Okay, the null and the alternate hypotheses. The null involves the equals. The alternate is whatever is the case if the null hypothesis is thrown away. Okay, another way it might work out is, let's say we have this claim the average test score was less than or equal to 82. See that or equal right there? A null hypothesis is a mathematical claim that involves equality, less than or equal to 82. That does have the equality, the equals in it. The way that we might write that down is H naught. I forgot to mention the H with the subscript 0. The symbol we use for the null hypothesis is sometimes read H naught. Okay. Well, the way we would write that is, well, think about it. How would you write less than or equal to 82? X bar for average test score, less than or equal to 82. What's the other side of that? What if you thought that that wasn't true? Then we would say the average test score was just greater than 82. So we got less than or equal to 82, 82 or less. The other side of that is more than 82. Okay, so the alternate would be X bar is greater than 82. One last one, the average test score was greater than or equal to 82. Okay, greater than or equal to 82. It involves equality and so on. So the null hypothesis would be X bar is greater than or equal to 82. And then the alternative to that would be that the average test score was less than 82. So if that seems strange when you first saw it, these are the only possibilities. Equals, not equals, less than or equal to, greater than or equal to, less than. Okay, those are all the ways that you will see a null and alternate hypothesis work out in the problems. Okay. All right, now I think we got enough to talk about this problem right here. So this was my goal from the beginning of the video, was to discuss this problem. And I'll read it and I'll tell you how I would think about it, dissect it, and answer it regarding what I've already told you. Oh, one more thing. I I never really defined a type 1 and type 2 error in the context of a null hypothesis. Okay, yeah, because when we actually do statistics, we don't talk about are all house cats gray or not. Okay, we talk about null and alternate hypotheses. Okay, so type 1 and type 2 errors are discussed in the context of the null hypothesis. So here's how it works out. A type 1 error is that the null hypothesis is true, but you rejected it. You disbelieved it. Or you got to the point where you didn't believe it. Okay? Notice how I bold and italicized the word true, but rejected. Type 2 error, the null hypothesis turns out to be false, but is not rejected. Okay? Notice how I bold and italicized the words false and not rejected. All right? So those are mistakes, right? If something's true, but you don't believe it, you're wrong. Okay? And in this is a mistake too, right? If something's false, but you turn out to not reject it, which would amount to believing it or accepting it, that would be a mistake too. You would be wrong that way too. Okay. All right. So now when I see a problem or a situation on my math lab or the assignments anywhere, in the context of statistics, this is what type 1 and type 2 errors are. They're in the context of the null hypothesis. So I'm going to look at this problem right here in those terms. Okay. And I've made a little table here that I hope looks like this one that I started with, where I wanted to show you that basically there's two ways that we can be wrong here and two ways that we could be right. And you could see the distinction between type 1 and type 2 errors. Okay, so let's look at it like this. A local chess club claims that the length of time to play a game has a standard deviation of 11 minutes or more. So when I first read that and I see 11 minutes or more, that sounds like greater than or equal to. Greater than or equal to 11. In the context of statistics, then you tell me standard deviation. I use sigma, that's our symbol for standard deviation, and I put greater than or equal to 11. So I read that and I'm looking for like a mathematical statement, and I see greater than or equal to. And then I remember that the null hypothesis involves equality, and so that must be the null hypothesis we're working with, okay? All right, next thing is I'll put that in my table and I'll say, well, this is reality, here and here, and this is our decision here and here. So reality, I put the null hypothesis. It might be true that the standard deviation is greater than or equal to 11. Okay, so I'm going to put that like as if I was saying, well, one way it could work out is the null hypothesis is true. And right here is the alternate hypothesis. It might work out that in reality, the null hypothesis is false, which would put me into the alternate hypothesis, that the standard deviation is less than 11 minutes. Okay, all right. So reality is it's either greater than or equal to 11 as the null hypothesis proposes for us, or that it's not. All right. Okay, and then we have this decision that we accept that the null hypothesis is true, or we believe it. Sigma is greater than or equal to 11, or we reject it or disbelieve the null hypothesis. Okay, so we throw that out. Now, you see how we're correct. We accept it and it's true, or we reject it and it turns out that it was false. Okay, we're correct in both of those instances. But over here, I classified the type 1 and the type 2 errors. It's true, but you reject it, type 1. It's false, but you don't reject it, type 2. So that's why here I say I reject the null hypothesis, but it turned out to be true, type 1. I accept it, but it turned out to be false, type 2. Okay, so that's just my table. And I'm not saying you have to make a table to understand this or work the problem. That's just how I'm showing you, because I think it might be something that helps some people. Now, I'm going to put this table Now into my answer. Now this question is already answered. It has all the correct answers there. But if I was working this problem from scratch on my math lab, I would have to translate this information into the question. So a type 1 error, let's read this, will occur if the actual standard deviation of the length of time to play a game is, okay, greater than or equal to 11 minutes, but you reject the null hypothesis that the standard deviation is greater than or equal to 11 minutes. Do you see how, like, when I look at this part of the table, it encompasses up here in my answer that it turns out the null hypothesis is true. The standard deviation is greater than or equal to 11, but we reject it. Okay. All right. And then the second one, a type 2 error will occur if the actual standard deviation of the length of time to play a game is less than 11 minutes. So why is that? Okay, well, in reality, this what this first part of the question says, actual standard deviation is less than 11 minutes. That's this part right here. A type 2 error will occur if in reality the null hypothesis isn't true, which would mean that the standard deviation is less than 11 minutes, which is our alternate hypothesis. Whoops. Okay, so that's why this says less than 11 minutes. All right, type 2 error says that that's the reality of the situation. But you fail to reject. That means you accept it. Fail to reject. Well, what's another way to say that? Accepting it, believing it. I know that the terminology can seem ridiculous, that we could say it so many different ways, but fail to reject is what the option will be. Okay, but you see how it's the same thing as accepting or believing, so on. Okay, but you failed to reject the null hypothesis that the standard deviation is greater than or equal to 11 minutes. So that puts us right here. That's why type 2 error. It's like I'm reading it right off this chart. Okay. So I hope that that helps understand the concepts. There's not really a whole lot of math in this kind of problem, but we do have to understand what I think are three things. Seeing how hypotheses factor into decisions and realities, 2 ways to be right, 2 ways to be wrong. Then we have to understand what a null and alternate hypothesis is, okay? Then how type 1 and type 2 errors are defined in that context. So those are the 3 things I think you have to know to understand a question like this one.